Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
A patch for a vulnerability has been released, and a DevOps team needs to update their running containers in Google Kubernetes Engine (GKE). How should the DevOps team accomplish this? The options are: Option A, use Puppet or Chef to push out the patch to the running container. Option B, verify that auto upgrade is enabled. If so, Google will upgrade the nodes in a GKE cluster. Option C, update the application code or apply a patch, build a new image, and redeploy it. Option D, configure containers to automatically upgrade when the base image is available in Container Registry.
To arrive at the correct answer, we focus on the keywords: patch for a vulnerability, update their running containers, Google Kubernetes Engine, GKE.
The correct answer is option C, update the application code or apply a patch, build a new image, and redeploy it.
Why is this correct? C. Containers are designed to be immutable. To apply a patch, the best practice is to update the code or base image, build a new container image, and redeploy the updated image to the GKE cluster. Why are the others incorrect? A. Containers should be treated as immutable. Using configuration management tools like Puppet or Chef to patch running containers violates this principle. B. GKE auto upgrade is for upgrading the Kubernetes node operating system and cluster components, not the application containers running within the cluster. D. GKE does not natively support automatically upgrading running application containers simply because a new base image becomes available in Container Registry.
An engineering team is launching a web application that will be public on the internet. The web application is hosted in multiple GCP regions and will be directed to the respective backend based on the URL request. Your team wants to avoid exposing the application directly on the internet and wants to deny traffic from a specific list of malicious IP addresses. Which solution should your team implement to meet these requirements? The options are: Option A, Cloud Armor. Option B, Network Load Balancing. Option C, SSL Proxy Load Balancing. Option D, NAT Gateway.
To arrive at the correct answer, we focus on the keywords: web application, multiple GCP regions, directed to the respective backend based on the URL request, avoid exposing the application directly on the internet, deny traffic from a specific list of malicious IP addresses.
The correct answer is option A, Cloud Armor.
Why is this correct? A. Cloud Armor works with global HTTPS load balancing, which handles multi-region URL routing, to protect applications from DDoS attacks and allows you to enforce security policies, such as denying traffic from specific IP addresses. Why are the others incorrect? B. Network Load Balancing is a regional, non-proxied load balancer that does not support URL-based routing or integration with Cloud Armor for IP filtering. C. SSL Proxy Load Balancing is intended for non-HTTPS TCP traffic. It does not support URL-based routing, which is required by this web application. D. NAT Gateway allows private instances to initiate outbound connections to the internet. It does not load balance incoming web traffic, route by URL, or provide ingress IP filtering.
A large e-retailer is moving to Google Cloud Platform with its e-commerce website. The company wants to ensure payment information is encrypted between the customer's browser and GCP when the customers check out online. What should they do? The options are: Option A, configure an SSL certificate on an L7 load balancer and require encryption. Option B, configure an SSL certificate on a network TCP load balancer and require encryption. Option C, configure the firewall to allow inbound traffic on port 443 and block all other inbound traffic. Option D, configure the firewall to allow outbound traffic on port 443 and block all other outbound traffic.
To arrive at the correct answer, we focus on the keywords e-commerce website, payment information is encrypted between the customer's browser and GCP.
Correct answer is option A. Configure an SSL certificate on an L7 load balancer and require encryption.
Why is this correct? A. An L7 HTTPS load balancer natively supports SSL/TLS termination. Configuring an SSL certificate on it securely encrypts HTTP web traffic between the customer's browser and GCP, fulfilling the e-commerce requirement. Why are the others incorrect? B. A network TCP load balancer operates at layer 4. While it can pass through encrypted traffic, L7 load balancers are specifically designed for HTTPS web traffic and provide centralized SSL termination. C. Firewalls only control network access by allowing or blocking ports. Allowing inbound port 443 permits HTTPS traffic to enter, but it does not actively implement or manage the required SSL encryption. D. Outbound firewall rules control traffic leaving the network, which does not secure the incoming payment information from the customer. Moreover, firewalls alone cannot configure or provide SSL encryption.
Your organization is migrating a complex application to Google Cloud. The application has multiple internal components that interact with each other across several Google Cloud projects. Security is a major concern, and you must design an authorization scheme for administrators that aligns with the principles of least privilege and separation of duties. What should you do? The options are: Option A, identify the users who will migrate the application, revoke the default user roles and assign the users with purposely created custom roles. Option B, use multiple external identity providers, IDP, configured to use different SAML profiles and federate the IDPs for each application component. Option C, configure multi-factor authentication, MFA, to enforce the use of physical tokens for all users who will migrate the application. Option D, no action needed. When a Google Cloud organization is created, the appropriate permissions are automatically assigned to all users in the domain.
To arrive at the correct answer, we focus on the keywords authorization scheme for administrators, principles of least privilege, separation of duties.
The correct answer is option A. Identify the users who will migrate the application, revoke the default user roles and assign the users with purposely created custom roles.
Why is this correct? A. Custom roles allow precise specification of permissions, effectively implementing the principles of least privilege and separation of duties by granting only the exact access needed and revoking overly broad default roles. Why are the others incorrect? B. External IDPs and SAML profiles address identity federation and authentication, not an authorization scheme for administrators, and do not inherently enforce least privilege. C. Multi-factor authentication, MFA, improves authentication security but does not define an authorization scheme or enforce least privilege and separation of duties. D. Default permissions in Google Cloud are typically broad. Relying on default roles violates the principles of least privilege and separation of duties, requiring explicit custom configurations instead.
You are a security administrator at your company and are responsible for managing access controls, identification, authentication, and authorization on Google Cloud. Which Google recommended best practices should you follow when configuring authentication and authorization? Choose 2. The options are: Option A, use Google default encryption. Option B, manually add users to Google Cloud. Option C, provision users with basic roles using Google's Identity and Access Management (IAM) service. Option D, use SSO/SAML integration with Cloud Identity for user authentication and user lifecycle management. Option E, provide granular access with predefined roles.
To arrive at the correct answer, we focus on the keywords, managing access controls, identification, authentication, and authorization. Google recommended best practices, configuring authentication and authorization.
The correct answers are option D, use SSO/SAML integration with Cloud Identity for user authentication and user lifecycle management. And option E, provide granular access with predefined roles.
Why is this correct? D. Integrating SSO/SAML with Cloud Identity is a recommended best practice for centralizing user authentication and streamlining identity lifecycle management. E. Providing granular access using predefined roles enforces the principle of least privilege, which is a core security best practice. Why are the others incorrect? A. Encryption is a mechanism for data protection and confidentiality, not a method for managing user authentication and authorization. B. Manually managing users scales poorly and increases administrative overhead. Federating identities via SSO is the recommended approach. C. Basic, primitive roles provide overly broad permissions and violate the principle of least privilege. Predefined roles should be used instead.
Your organization has implemented synchronization and SAML federation between Cloud Identity and Microsoft Active Directory. You want to reduce the risk of Google Cloud user accounts being compromised. What should you do? The options are: Option A, create a Cloud Identity password policy with strong password settings, and configure two-step verification with security keys in the Google Admin Console. Option B, create a Cloud Identity password policy with strong password settings, and configure two-step verification with verification codes via text or phone call in the Google Admin Console. Option C, create an Active Directory domain password policy with strong password settings, and configure post-SSO, single sign-on, two-step verification with security keys in the Google Admin Console. Option D, create an Active Directory domain password policy with strong password settings, and configure post-SSO, single sign-on, two-step verification with verification codes via text or phone call in the Google Admin Console.
To arrive at the correct answer, we focus on the keywords, synchronization and SAML federation, Cloud Identity and Microsoft Active Directory, reduce the risk, user accounts being compromised.
The correct answer is option C, create an Active Directory domain password policy with strong password settings, and configure post-SSO, single sign-on, two-step verification with security keys in the Google Admin Console.
Why is this correct? C. With SAML federation, Active Directory acts as the identity provider, so password policies must be enforced within AD. Enabling post-SSO two-step verification with security keys in Google provides strong, phishing-resistant MFA, maximally reducing account compromise risk. Why are the others incorrect? A. Because SAML federation is used, authentication is delegated to Active Directory, making a Cloud Identity password policy ineffective. B. A Cloud Identity password policy is ineffective because AD manages passwords. Furthermore, SMS or phone verification codes are vulnerable to phishing and SIM swapping. D. Although managing the password policy in Active Directory is correct, SMS and phone verification codes are susceptible to phishing, making them less secure than security keys.
A company allows every employee to use Google Cloud Platform. Each department has a Google group, with all department members as group members. If a department member creates a new project, all members of that department should automatically have read-only access to all new project resources. Members of any other department should not have access to the project. You need to configure this behavior. What should you do to meet these requirements? The options are: Option A, create a folder per department under the organization. For each department's folder, assign the project viewer role to the Google group related to that department. Option B, create a folder per department under the organization. For each department's folder, assign the project browser role to the Google group related to that department. Option C, create a project per department under the organization. For each department's project, assign the project viewer role to the Google group related to that department. Option D, create a project per department under the organization. For each department's project, assign the project browser role to the Google group related to that department.
To arrive at the correct answer, we focus on the keywords, creates a new project, automatically have read-only access to all new project resources, members of any other department should not have access to the project.
The correct answer is option A, create a folder per department under the organization. For each department's folder, assign the project viewer role to the Google group related to that department.
Why is this correct? A. Creating a folder per department allows organizational isolation. Assigning the project viewer role at the folder level ensures that all newly created projects within that folder automatically inherit read-only access to all project resources for the assigned Google group. Why are the others incorrect? B. The project browser role only provides read access to the project hierarchy and metadata. It does not grant read-only access to the actual resources within the project, which is required. C. Assigning permissions to a single project per department does not automatically apply those permissions when a department member creates a new project. Folder-level inheritance is required for this behavior. Why are the others incorrect? D. Creating a single project per department fails to automatically grant access for newly created projects. Furthermore, the project browser role does not provide read-only access to the actual project resources.
You are a member of the security team at an organization. Your team has a single GCP project with credit card payment processing systems alongside web applications and data processing systems. You want to reduce the scope of systems subject to PCI audit standards. What should you do? The options are: Option A, use multi-factor authentication for admin access to the web application. Option B, use only applications certified compliant with PADSS. Option C, move the cardholder data environment into a separate GCP project. Option D, use VPN for all connections between your office and cloud environments.
To arrive at the correct answer, we focus on the keywords, single GCP project, reduce the scope of systems subject to PCI audit standards.
The correct answer is option C, move the cardholder data environment into a separate GCP project.
Why is this correct? C. GCP projects provide strong isolation and trust boundaries. Moving the cardholder data environment into a separate project isolates it from non-payment systems, effectively limiting the PCI DSS audit scope to only that isolated project. Why are the others incorrect? A. Implementing multi-factor authentication is a security requirement for PCI DSS but does not isolate systems or reduce the overall scope of the audit. B. Using PADSS certified applications is important for payment processing but does not provide the infrastructure isolation needed to reduce the audit scope of the GCP environment. D. A VPN secures transit between your office and the cloud, but it does not segment or isolate internal GCP systems to reduce the PCI audit scope.
You have been tasked with inspecting IP packet data for invalid or malicious content. What should you do? The options are: Option A, use packet mirroring to mirror traffic to and from particular VM instances. Perform inspection using security software that analyzes the mirrored traffic. Option B, enable VPC flow logs for all subnets in the VPC. Perform inspection on the flow logs data using cloud logging. Option C, configure the Fluent agent on each VM instance within the VPC. Perform inspection on the log data using cloud logging. Option D, configure Google Cloud Armor access logs to perform inspection on the log data.
To arrive at the correct answer, we focus on the keywords, inspecting IP packet data, invalid or malicious content.
The correct answer is option A, use packet mirroring to mirror traffic to and from particular VM instances. Perform inspection using security software that analyzes the mirrored traffic.
Why is this correct? A. Packet mirroring clones traffic, including payload data, and forwards it to out-of-band security appliances for deep packet inspection to identify malicious content. Why are the others incorrect? B. VPC flow logs only capture network flow metadata, like source and destination IPs and ports, not the actual packet payload required for content inspection.
C. The Fluent agent is designed to capture application and system logs from the VM instance, not raw IP packet payloads traversing the network. D. Google Cloud Armor access logs only provide information on HTTP/HTTPS requests evaluated by its policies, not the raw IP packet data needed here.
Which Google Cloud service should you use to enforce access control policies for applications and resources? The options are: Option A, Identity-Aware Proxy. Option B, Cloud NAT. Option C, Google Cloud Armor. Option D, Shielded VMs.
To arrive at the correct answer, we focus on the keywords: enforce access control policies, applications, and resources.
The correct answer is option A, Identity-Aware Proxy.
Why is this correct? A. Identity-Aware Proxy, IAP, establishes a central authorization layer, allowing you to enforce access control policies for applications and VMs running on Google Cloud based on user identity and context. Why are the others incorrect? B. Cloud NAT allows resources without external IP addresses to access the Internet, but it does not manage or enforce access control policies. C. Google Cloud Armor provides DDoS protection and Web Application Firewall (WAF) capabilities, rather than identity-based access control policies. D. Shielded VMs protect compute instances against boot or kernel-level malware to ensure integrity. They do not enforce access control for applications.
You perform a security assessment on a customer architecture and discover that multiple VMs have public IP addresses. After providing a recommendation to remove the public IP addresses, you are told those VMs need to communicate to external sites as part of the customer's typical operations. What should you recommend to reduce the need for public IP addresses in your customer's VMs? The options are: Option A, Google Cloud Armor. Option B, Cloud NAT. Option C, Cloud Router. Option D, Cloud VPN.
To arrive at the correct answer, we focus on the keywords: VMs have public IP addresses, remove the public IP addresses, VMs need to communicate to external sites, reduce the need for public IP addresses.
The correct answer is option B, Cloud NAT.
Why is this correct? B. Cloud NAT enables VMs without external IP addresses to connect to the Internet in a secure and controlled manner. It performs outbound network address translation, allowing VMs to reach external sites while preventing unwanted inbound connections. Why are the others incorrect? A. Google Cloud Armor is a web application firewall and DDoS protection service. It protects incoming traffic to your applications but does not facilitate outbound Internet communication for VMs lacking public IP addresses. C. Cloud Router is used to dynamically exchange routes between your VPC and on-premises networks using BGP. It does not provide network address translation for outbound Internet access. D. Cloud VPN provides secure, encrypted connections between your on-premises network and your GCP VPC over the public Internet. It does not provide general Internet access for private VMs.
You need to connect your organization's on-premises network with an existing Google Cloud environment that includes one shared VPC with two subnets named production and non-production. You are required to use a private transport link. Configure access to Google Cloud APIs through private API endpoints originating from on-premises environments. Ensure that Google Cloud APIs are only consumed via VPC Service Controls. What should you do? The options are: Option A, 1. Set up a Cloud VPN link between the on-premises environment and Google Cloud. 2. Configure private access using the restricted.googleapis.com domains in on-premises DNS configurations. Option B, 1. set up a partner interconnect link between the on-premises environment and Google Cloud. 2. Configure private access using the private.googleapis.com domains in on-premises DNS configurations. Option C. 1. Set up a direct peering link between the on-premises environment and Google Cloud. 2. Configure private access for both VPC subnets. Option D. 1. Set up a dedicated interconnect link between the on-premises environment and Google Cloud. 2. Configure private access using the restricted.googleapis.com domains in on-premises DNS configurations.
To arrive at the correct answer, we focus on the keywords, private transport link, originating from on-premises environments, VPC Service Controls.
The correct answer is option D. 1. Set up a dedicated interconnect link between the on-premises environment and Google Cloud. 2. Configure private access using the restricted.googleapis.com domains in on-premises DNS configurations.
Why is this correct? D. Dedicated interconnect provides a private transport link. Configuring private access using the restricted.googleapis.com domain ensures that Google Cloud APIs are only consumed via VPC Service Controls. Why are the others incorrect? A. Cloud VPN traverses the public internet and does not meet the requirement of using a private transport link. B. While Partner Interconnect provides a private transport link, the private.googleapis.com domain does not enforce VPC service controls. C. Direct peering provides public IP reachability to Google services rather than a private transport link, and does not configure restricted.googleapis.com.
A customer wants to move their sensitive workloads to a compute engine-based cluster using managed instance groups, MIGs. The jobs are bursty and must be completed quickly. They have a requirement to be able to control the key lifecycle. Which boot disk encryption solution should you use on the cluster to meet this customer's requirements? The options are: Option A, Customer-Supplied Encryption Keys, CSEK. Option B, Customer-Managed Encryption Keys, CMEK, using Cloud Key Management Service, KMS. Option C, Encryption by default. Option D, pre-encrypting files before transferring to Google Cloud Platform, GCP, for analysis.
To arrive at the correct answer, we focus on the keywords, managed instance groups, MIGs, bursty and must be completed quickly, control the key lifecycle, boot disk encryption.
The correct answer is option B, Customer Managed Encryption Keys, CMEK, using Cloud Key Management Service, KMS.
Why is this correct? B. CMEK integrates directly with Cloud KMS, providing full control over the key lifecycle. It seamlessly supports managed instance groups, ensuring bursty workloads can scale quickly without external key provisioning delays. Why are the others incorrect? A. CSEK requires the customer to manage keys externally and provide them for operations, adding operational complexity and potential latency that hinders rapidly scaling bursty workloads. C. Encryption by default uses Google managed keys, meaning the customer does not have control over the key lifecycle, failing to meet the core requirement. D. Pre-encrypting files only protects data at the application layer. It does not provide the required boot disk encryption for the compute engine instances.
You work for a healthcare provider that is expanding into the cloud to store and process sensitive patient data. You must ensure the chosen Google Cloud configuration meets these strict regulatory requirements. Data must reside within specific geographic regions. Certain administrative actions on patient data require explicit approval from designated compliance officers. Access to patient data must be auditable. What should you do? The options are: Option A, select a standard Google Cloud region. Restrict access to patient data based on user location and job function by using Access Context Manager. Enable both cloud audit logging and access transparency. Option B, deploy an assured workloads environment in an approved region. Configure access approval for sensitive operations on patient data. Enable both cloud audit logs and access transparency. Option C. Deploy an assured workloads environment in multiple regions for redundancy. Utilize custom IAM roles with granular permissions. Isolate network-level data by using VPC Service Controls. Option D. Select multiple standard Google Cloud regions for high availability. Implement access control lists, ACLs, on individual storage objects containing patient data. Enable cloud audit logs.
To arrive at the correct answer, we focus on the keywords: sensitive patient data, strict regulatory requirements, data must reside within specific geographic regions, administrative actions on patient data require explicit approval, access to patient data must be auditable.
The correct answer is option B. Deploy an assured workloads environment in an approved region. Configure access approval for sensitive operations on patient data. Enable both cloud audit logs and access transparency.
Why is this correct? B. Assured workloads enforces data residency for regulatory compliance. Access approval ensures explicit approval is required for administrative actions. Cloud audit logs and access transparency provide comprehensive auditability of data access. Why are the others incorrect? A. Standard regions lack strict compliance enforcements provided by assured workloads. Access Context Manager controls access based on attributes but does not require explicit approval for administrative actions. C. Custom IAM roles and VPC service controls do not satisfy the specific requirement for explicit approval workflows for administrative actions on patient data. D. ACLs do not provide explicit approval mechanisms for administrative actions. Standard regions also lack the compliance and data residency enforcements of assured workloads.
Your privacy team uses crypto shredding, deleting encryption keys, as a strategy to delete personally identifiable information, PII. You need to implement this practice on Google Cloud while still utilizing the majority of the platform's services and minimizing operational overhead. What should you do? The options are: Option A. Use client-side encryption before sending data to Google Cloud, and delete encryption keys on premises. Option B. Use Cloud External Key Manager to delete specific encryption keys. Option C. Use customer-managed encryption keys to delete specific encryption keys. Option D. Use Google Default Encryption to delete specific encryption keys.
To arrive at the correct answer, we focus on the keywords: crypto shredding, utilizing the majority of the platform's services, minimizing operational overhead.
The correct answer is option C. Use customer-managed encryption keys to delete specific encryption keys.
Why is this correct? C. Customer-managed encryption keys, CMEK, via Cloud KMS integrates seamlessly with most Google Cloud services, allowing you to manually delete specific keys for crypto shredding while minimizing operational overhead. Why are the others incorrect? A. Client-side encryption prevents Google Cloud services from natively processing the data, violating the requirement to utilize the majority of the platform's services. B. Cloud External Key Manager, EKM, requires you to maintain and operate an external key management system, which significantly increases operational overhead compared to using CMEK. D. Google Default Encryption manages keys automatically on your behalf, so you do not have the capability to manually delete specific encryption keys for crypto shredding.